Hi, everybody. This is Mr. Folly, and welcome to Podcast 2.1. We're going to talk a little bit about naming. We're going to name ionic compounds. We're going to talk about Roman metals. We're going to talk about reducing some subscripts. We're going to talk about polyatomic ions, and we're going to talk about molecular compounds and acids. All right. You can find the charge of an ion from the periodic table. Okay. So everything in this first column is plus 1. Everything in the second column is plus 2. Everything in this third column is plus 3. This right here I'm going to call 0. Everything here is minus 3, minus 2, minus 1, 0. Now, there are a few things that are odd. These guys right here have multiple charges, so we don't say they always have the same charge. With the exception of zinc, that is always plus 2. Please mark that on your periodic table. And silver is plus 1. Mark that on your periodic table. You do have periodic tables that I gave you in class first day with equation sheets and stuff on it. So if I picked a number, say I picked number 34 and said, what would I expect the charge of the ion for 34 to be? Well, 34 is selenium. That would have a negative 2 charge. Okay? So that's it to get the charges from the periodic table. These guys are big question marks, meaning we need something else that has to tell us. And these guys down here will not be used, but they have variable charges as well. So I suppose I can stop playing crisscross now. I just love it so much. I forgot. All right, so ionic compounds start with a metal. They form networks, not molecules. Now, a molecule is like water, which has a distinct beginning and end, oxygen and 2 hydrogens. Ionic compounds form networks like this. See how they go over and over and over and over and over and over and over again? These networks, for us, when we write a formula, is a formula unit. So like NaCl is an ionic compound. It starts with the metal Na. Oh, let me tell you where the metals are. Dun, 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 dun. This is very important. Sketch this into your periodic table as well. This is our dividing line. Everything on the left is a metal, and everything on the right of that stair step is a non-metal. Okay? So when I look at sodium, it's over here on the left of it, it's a metal. Now the exception to that are the ones I'm going to shade right here, and they are the semi-metals. Okay? We don't use the semi-metals in naming very often at all. Means we won't use them at all. Aluminum, of course, is a metal. If you didn't know that, shame on you. Their aluminum cans are made out of metal. But you learned it now, so the shame is gone. Okay, so NaCl is a network. It's a metal. So see this? This big guy right here is the chlorine, sodium, chlorine, sodium, chlorine, sodium. See how they're networked? And that could go on for many, 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 many cubes. All right. Binary ionic. Binary, you don't really need to know that it's binary. But binary just means there's 2 types. Not 2 atoms, 2 types. And what we do for these, what you can do is crisscross the charges. Okay? So you'll have Roman metals, which I'll talk about now. And the charges have to cancel. All right. So if I have barium chloride, I look at barium on my periodic table. Barium on the periodic table is number 56. So if you're playing along at home, that means it's in the plus 2 column. Chloride is number 17. That means it's in the minus 1 column. Plus 1, plus 2, woo, plus 3, 0, minus 3, minus 2, minus 1, 0. So barium was right here, chlorine was right here. Now these charges need to cancel out. So to make them cancel out, I need another chlorine. So that means barium, chlorine, chlorine would be written as BaCl2. See how the 2 up here crisscrosses down, the 1 crisscrosses down. No charges are shown here. Copper 2 nitride. Now copper is right in here. And this is our mystery spot, right? But if I tell you that copper, whose symbol is Cu, copper 2, that tells me that copper is plus 2. Okay? Nitride is over here in the negative 3 spot, excuse me. So that means it's going to be negative 3. So to balance it, crisscrossing makes it nice and fast and easy because you go, oh, Cu, 3 comes down here, N comes over here, 2. Now I talk about how copper has these Roman numerals. That's why I call that region the Roman region. And the Roman region is in the middle. Go back to my periodic table again. It includes these guys. So if you're under the stair step and in that crossbar, That bloody mess right there is the Roman region. That means you need a Roman numeral. So there it told me that it was copper plus 2. Now, why don't I call barium barium 2? Well, there's only one barium out there. There's more than one copper out there. So there's a copper 2, there's also a copper 1. So you have to say which one. Okay? So in my high school, there were 2 girls named Amy Roberts. One Amy Roberts had kind of snaggly teeth. The other Amy Roberts had kind of regular teeth. Okay? So whenever we were talking about the Amy Roberts, we always said, well, there's the Amy Roberts with the snaggly teeth or the Amy Roberts without the snaggly teeth. So that was kind of the thing that we did. We had to identify those. But we never had to say, well, which, we also had, we'll draw a little differently, Mark Kifowit. Mark Kifowit, you didn't have to say the Mark Kifowit with the snaggly teeth because there was only one Mark Kifowit. So hopefully that makes sense. All right, magnesium oxide. Magnesium is in the plus 2 column. Mg, right at my plus 2. Oxide is in the minus 2 column. Remember, notice the ides? That just means look for the element, but change your ide to ene, basically. O is negative 2. Now, in this one, if you're a fool, you would write Mg2O2, but we're no fool. We see that reduces. Remember, the purpose is to cancel the charges. MgO. All right. Ding, ding, ding. Ternary ionics are the same thing, but ternary means 3 or more. And you don't need to know the word ternary. It just means it's going to have one of the ions you have to memorize. Okay? Still going to subscript, but we're going to add parentheses to this. Okay? So calcium is in that plus 2 spot, and acetate is on your ion list. That ion list is on Canvas. And acetate is everybody's favorite, C2H3O2 negative 1. Now to make these balance, I can tell I need 2 of these guys. The way I show that I have 2 is I write Ca parentheses C2H3O2 taken twice. Over here I have iron 3 nitrate. Iron, I don't know iron's charge. Oh, the Roman numeral 3 tells me it's plus 3. Nitrate is on your ion sheet. It's NO3 minus 1. So to balance that out, I have Fe. Get those charges. I have 1. I shouldn't have put the 1 there. NO3 taken thrice. Uh-oh, now I need to name it the other way. So Fe I know is iron. Now, iron is in that long crossbar part, so I don't know its charge. But phosphate is on my ion list, and it's PO4 negative 3. So if it takes 1 iron to cancel out a negative 3, iron must be iron 3. And then PO4 is phosphate. See why it's important to learn your ions? It is. It is. Binary molecular. So it starts with a nonmetal. Remember on the periodic table we said, oh, there's the stair step. And those are your nonmetals. You name it with prefixes, and they make molecules, not networks. Your prefixes are mono, di, tri, tetra, and this is in order, penta. And you don't use much past penta, but I'll give them to you anyway. Hexa, hepta, octa, and nona. All right, so make molecules, not networks. So NO2. I have 1 nitrogen, so I'm going to get into the weird, annoying little names, quirks on this. Nitrogen, and then I have 2 oxygens, dioxide. And that makes me remember, oh yeah. So when I name with these guys, I name with prefixes, but no prefix for the first mono. So if the second one is mono, so it was NO, NO, it would be nitrogen, no prefix on the first mono, monoxide. Because you do use mono in the second one if it's a mono. Okay? Now notice, you never have no AO, and no OO. Ooh. So for example, this is monoxide, not monoxide. Okay? This is wrong. No double O. And the last part is it has to end in "ide." and sound good. I know that sounds impossible to be really the rule, but it works. So if I have sulfur, sulfur is sulfide. If I have nitrogen, ooh, is that nitrogenide? Is that nitrowide? Is it nitride? Of course it's nitride. So if you just play around with the words, you'll find the ones the best. Acids, naming acids. First of all, anything that starts with an H says, hello, I'm an acid. Look, hello, I'm an acid. Hello, I'm an acid. Hello, I'm an acid. Hello, I'm an acid. Okay. Acids are ionically bonded, but they don't form networks. 8 becomes something, ic, acid. Ite becomes something, us, acid. Now the something, I'll do that in a second. Ide becomes hydro, something, ic, acid. So for example, if I had chlorate is ClO3, chlorate is ClO3, identify that, I'll memorize that. That would be, chlorate becomes the stem, chloric acid. If I have bromite, bromite is BrO2, so HBrO2 would be the acid. That would be, the stem would be bromous acid. And then if I had HCl, everybody's favorite, Cl is chloride. Remember, if it's one element with just one element with a negative charge, it's going to end in ide. So that would be hydrochloric acid. So HClO2, this is chlorite, right? So chlorite means it turns into us. So this is chlorus acid. This SO4 right here, SO4 negative 2, is sulfate. So that's going to be, 8 becomes sulfuric acid. Hydrobromic acid comes from bromide. That's going to be HBr. Hydrates. They're loosely bonded to water. Water to an ionic compound. You'll see them, they'll have a .H2O. It's a network with one ionic compound surrounded by water molecules. So what you do is you name parts. Name, ionic, and then prefix hydrate. So maybe you heard the bell ring. This is copper 2. Using the same naming rules before. Sulfate, that's an ion we looked up. And then it would be hexa, that's 6, hydrate. MgCO3 is magnesium carbonate. And carbonate's one of the ions you have to learn. And then that's a 3, prefix for 3 is trihydrate. And aluminum sulfate tetrahydrate would be aluminum sulfate. I crisscrossed my charges here. And then tetrahydrate would be .4H2O. And I hope my review slide's the next one because the class is starting. Names are systems we must learn. The first atom type IDs it. Know your ions, and we will keep on working. Toodles. As soon as I can find out how to cancel this again.